All right, chapter 1 to 3 is posted, and now I'm working on chapter 4 and 5. Let's go. Okay, this one's kind of messy because I already did it, but let's read it through. The piston in a motorcycle engine moves up and down 100 times every second. It moves a total distance of 12 centimeters from the top to the bottom, and the motion of the piston is modeled using a cosine function. What is the amplitude of this function? So if it moves a total distance from the very top to the very bottom, a maximum of 12 centimeters, then that's from the max and to the min is 12. So the amplitude would be half of that, so 6. The amplitude is 6. What is the period of the function? They said the piston goes up and down 100 times in 1 second. So the time it takes to go up and down once would be 1 over 100, or 1/100th of a second. The period helps us determine k. K is equal to 2 pi divided by the period. So 2 pi divided by 1 over 100 ends up being 200 pi. So with all of these things in mind, the amplitude of 6, the period of 200 pi, and then our equation of the axis will also be 6, assuming that the bottom is 0, and we're going from 0 to 12, so then that would be halfway through. So then our equation then would be 6 cosine 200 pi x plus 6. Okay, for number 16, we know that a sine function has an amplitude of 3, a period of pi, and a vertical translation I'm going to assume upwards of 1. If it passes through the point pi by 3, 1, what is the phase shift? So I think what I'm going to do is come up with the equation first. So in order to come up with the equation, I know that the amplitude is 3, so here's the 3. Now what I'm looking for is the k that would go here. And k would be equal to the 2 pi divided by the period, which is pi. So k is 2. I'm going to put 2 here. Okay, so you'll notice I put the 2 for the k. And then I don't know the phase shift, that's what I'm trying to figure out, and then plus 1 is the vertical translation. We know that it passes through the point pi by 3 by 1, so how is that going to help us? By putting the point x equal to pi by 3 and y equal to 1 into the equation, I can actually isolate for d. In number 18, x belongs to between 0 and 2 pi here at the top, and we're going to solve the equation sec x minus 5 equals 0. I know that sec x is 1 over cos x minus 5, and so I'm going to rearrange. Rearranging, I get cos x equals 1 over 5. I'm going to draw my cast diagram here, and I'm going to find the inverse cos, the arc cos of, or cos to the negative 1, whatever you want to call it, of 1/5. And I'm going to know that cos, so 1/5 is positive, so I need to go into the 2 quadrants where cos is positive. So my angles are going to be in these 2 quadrants. The inverse cos of 1/5 is 1.36, so that means that the related angle is 1.36. So our first angle then will be 1.36. Our second angle will be 2 pi minus 1.36, or 4.92. So this would be the angle going all the way around here, 4.92 radians. Good job. In 18b, we're solving 12 sine squared x minus sine x minus 1. You'll notice that it looks kind of quadratic-like, so there's a squared term, a non-squared term, and then a constant term. So I'm going to substitute the sine x with a y. So I have 12y squared minus y minus 1, and so I can now factor that. So the factors of 12y squared minus y minus 1 are 3y minus 1 and 4y plus 1. And then we're still equal to 0. So now I can solve for y. Putting sine x back into those factors, because y is sine x, I get 3 sine x minus 1 and 4 sine x plus 1 are equal to 0. Rearranging those two possible equations, I get sine x equals 1/3 or sine x equals negative 1/4. On the left side here, I've drawn my cast diagram in the corner, so if 1/3 is positive, that means I need to be in these two quadrants at the top. So on my calculator, I find out the sine inverse of 1/3, and I get 0.3398. That means that this related angle and this related angle are 0.3398. So the first angle then is 0.3398, and the second angle coming all the way around here will be 1 pi minus 0.3398, so 2.802. Similarly on this side, we're going to do the same thing, only this time sine is negative. So over here, sine x equals negative 1/4. On my calculator, I'm going to ignore the negative because my cast diagrams takes care of when sine's negative. So sine's negative in the bottom two quadrants. I put in my calculator the inverse of sine of 1/4, and then I get 0.2527. Now that is not one of the answers. That is the related acute angle that's in here, the little one in here, and the little one in here. So the first one will be pi plus the 0.2527, and the second one will be 2 pi, so the whole 2 pi minus the 0.2527. So I get x equals 3.39, and then x equals 6.03.